Here we are going to round the numbers. Now, in order to round the numbers, we need to know how many sig figs do we need to round them to. What we are going to do is, starting with the first number, we will round it to one less sig fig and then one more less sig fig, and so on until we are only at one significant figure. So in a previous video we saw that there were 5 sig figs in this number, and therefore we will have to round it to 4 sig figs. And so if it is 4 sig figs, what would it be? Let's see. Four sig figs of this should be 0.002051. Okay, because this is a 7, the fifth sig fig is a 7, which is 5 and up. Anytime the digit at which you are cutting off your figure, so if you are going to cut it up right here, chop it off right there, then the digit of that follows, which is the 7 here. If it is 5 or up, then the previous digit goes up by 1, and then you drop everything else, which is what we did here. All right, the other one here, the next number, when we round this to one less sig fig, from 6 sig figs to 5 sig figs, it's going to be 100.03. Next one, this one is 1, 2, 3, 4, 5 sig figs. Remember, this 0 was not significant. When this number is rounded to 4 sig figs, some of you might be tempted to say it's going to be 2800, 2800, but that is not the case. Because imagine if somebody owes you $28,001 and you tell them to round it to the nearest digit and they give you 2800. That would be totally off. That's what we are talking about here. To round it to 4 sig figs, we would basically have to change the 1 here to a 0. But now we have another problem, because when we look at this number, we have these trailing zeros and they are not significant. So we only have 2 sig figs. How do we say that we have 4 sig figs? One way would be to introduce a decimal point, which should be here, but that would turn it into a 2800 again. So the only way to correctly show this to 4 sig figs is 2.800 times 10 to the 1, 2, 3, 4. All right, that will convert it to 4 sig figs. The coefficient part contains all the sig figs, and we have the 4 sig figs we want to show. Okay, the next number, one less sig fig, which means from 1, 2, 3, 4, 5, 6, 7 sig figs to 6 sig figs, is simply going to be, if we keep it in scientific notation, 2.97305 times 10 to the -3. Next one, to 2 sig fig, from 2 sig figs to 1 sig fig. 1.7 when rounded to 1 sig fig will be 2 times 10 to the -8. And finally 10200 from 3 sig figs to 4 sig figs will look the same. But how do we say that the last 0 now is not significant? This one. However, the 0 before it is significant. We have to state this only in scientific notation, which gives us 1.020 times 10 to the 1, 2, 3, 4. All right. So this is us rounding these numbers by one less sig fig. What if we wanted to round them to 2 less sig figs? So Let's see how to do that. Let's undo our work and try to round it to 2 less sig figs for each one of them. All right, so 2 less sig figs for the first one would be from 5 sig figs to 3 sig figs. That would be 0.00205. Notice that the next digit is a 0, this one here, and because it's less than 5, we simply drop that and everything else that follows, and we don't need to increase our previous digit, the 5, by anything. Next number, which is 6 sig figs, when rounded to 4 sig figs, it will be simply 100.0. Okay, we are dropping everything after here because it's less than 5. Next, we have 280,010. When that's rounded from currently, which is 5 sig figs, to 3 sig figs, we would have to have 280,000, which must be written in scientific notation to show 3 sig figs, which would be 2.80 times 10 to the 1, 2, 3, 4, 5. Okay. Next one, we have 1, 2, 3, 4, 5, 7 sig figs to 5 sig figs would make this 2.973, and because we are cutting it off right here, it's a 5, so we need this to be a 1 now, because we are dropping the 5, but we need to increase the previous digit by whatever value it has plus 1. So 0 plus 1 is a 1, making it 2.9731 times 10 to the negative 3. Next one, this one we already have 2 sig figs, and we rounded it previously to 1 sig fig, making it 2 times 10 to the negative 8. There is no such thing as 0 sig figs, and so there is nothing we can do about that one. The next one, we had 3 sig figs. We rounded it earlier to 2 sig figs. Now we want to round it to 1 sig fig. 1 sig fig is simply going to be 10,000. Right? We are cutting off right here. Now, if you wanted to, you can state this in scientific notation as 1 times 10 to the 4. It's up to you. In this case, the middle one, this number here, doesn't convey false information because by default these zeros are not significant, and we only have 1 sig fig here. All right, continuing, we will now round all the numbers that we can to 3 less sig figs. Basically, the last one, 5th one and 6th one, we cannot do anything about that, but the other ones we will do 3 less sig fig. Let's see what that will look like. Okay, so first one, from 5 sig figs to 3 less, making 2 sig figs, makes it 0.0021. Okay, we cut it up right there. Next one, from 6 sig figs to 3 less, making it 3 sig figs, simply makes it 100. But here we cut it off right here. But here we don't need to go to scientific notation. I could put a decimal point right there. That's gonna say that the zeros are significant. And if I do want to go to scientific notation, it's going to be 1.00 times 10 to the 2. Next one, from 5 sig figs to 3 less, meaning 2 sig figs, basically 28,000. Here we don't need to go to scientific notation either, but don't put a decimal point here, because then these zeros will become significant. If I want to write it in scientific notation, it should be 2.8 times 10 to the 1, 2, 3, 4, 5, 10 to the 5. And the next one from 7 sig figs, 3 less, making it 4 sig figs, meaning cutting it up here makes it 2.97, oops, 9 followed by 7, 3 times 10 to the negative 3. All right, the last two we cannot go any further. Now let's change this 4 from whatever sig figs we had, 1 less, meaning this time we have 3 less sig figs. Let's round them to 4 less sig figs than they actually have currently. So until we arrive at to 1 sig fig only for all of them. So 4 less sig figs. All right, so this is 5 sig figs, and 4 less sig figs will make this just 0.002. Okay, you'll cut off right there, and that would be the end of this number, because it cannot be, it's only 1 sig fig now. Next number, which is 6 sig figs, 4 less sig figs makes it 100 again. But the problem is, how do I state that this 0 here is significant but the next one is not? That's when I again need scientific notation. 1.0 times 10 to the 2. Okay. Next one, from 5 sig figs to 4 less, making it only 1 sig fig. That means I'm cutting it up here, but because the next number is an 8, which is greater than equal to 5, so the previous number goes up by 1, 3, and then I add the zeros to keep it in the same, keep that 3 in the same decimal place as the 2, which is in the 100,000s place. So I need to add 1, 2, 3, 4, 5 zeros. And if we want, we can write it in scientific notation as 3 times 10 to the 5. Next one, we have 4, 5, 6, 7 sig figs. 4 less will make it 3 sig figs, and it's simply going to be 2.97 times 10 to the negative 3. And the last two we already know, we already came to 1 sig fig. Here also we came to 1 sig fig for the first number, for the second number, and for the third number. The only one we need to continue moving down the sig fig lines is the fourth number. So I'm just going to do it here. Okay, the others are all addressed. So from 7 sig figs, we now want to go down to 5 sig figs. 5 sig fig means, look at the first 2 digits, which are my first 2 sig figs. The next one will be cut off. Because it is 7, that means the previous digit, the 9, goes up by 1. 9 going up by 1 makes it a 10. So you put a 0 for the 10, and the 1 of the 10 gets carried over to 3, making it 3.0 times 10 to the negative 3. Right? And finally, if it was only 1 sig fig, it would simply be 3 times 10 to the negative 3. That takes care of all of the rounding.